Hello friends, today we will discuss about the introduction of brushless DC motor. This brushless DC motor is a special kind of machine and it has wider application. Because of its specific feature, this has a specific application in different fields. Most of the known field of application of brushless DC motor is electrical vehicles. So in this lecture we will discuss the basics of brushless DC motor and we will go through the introduction of brushless DC motor. We will discuss what is brushless DC motor and how it has its similarities and dissimilarities with respect to conventional DC motor. So when we talk about brushless DC motor, they are polyphase synchronous motor and they have rotor consist of permanent magnet. Another special thing about the brushless DC motor is that they require an electronic control circuitry. So electronic control circuitry is mandatory for the brushless DC motor. So overall BLDC motor system consists of a motor, a solid state inverter and a rotor position sensor. Solid state inverter is a power converter, electronic converter which modifies the power according to the requirement, and it has switches which are turned on according to the requirement. And position sensor is a Hall effect sensor which gives the position of the rotor and detects the position of the rotor. On the basis of detection of the position of the rotor, corresponding output is generated from Hall effect sensor. If we talk about the construction, so schematic diagram of the brushless DC motor is with you. You can see this DC power supply is there and this is electronic control circuitry which we are talking about. This motor consists of two parts like all machines. It has a stator and it is a rotor. Rotor is basically consists of permanent magnet and stator has windings. So armature windings are available on the stator. Hall effect sensor will sense the position of the rotor and there are three Hall effect sensors H1, H2, H3, S1 in the figure. They will determine the position of the rotor. So on the basis of position of the rotor sensed by Hall effect sensor H1, H2 or H3, the corresponding excitation of binding of phase A, binding of phase B and binding of phase C is done, which determines the unidirectional or a particular direction rotation of the machine. So as we have seen in the figure, solid state inverters uses two type of switches. One is a transistor and another is a thyristor. The classification of transistor or application of transistor or thyristor based on the power rating. If the power rating is low, transistors are used, and if the power rating is high, thyristors are preferred. And the work of the position sensor is to determine the shaft position. On the basis of that, they send a control signal to the control circuitry to turn on the corresponding switch. So the corresponding switch of the inverter is get turned on and appropriate sequence of excitation is achieved. As we have seen that brushless DC motor construction is opposite to that of the conventional DC motor. In brushless DC motor, field poles are on rotor and armature winding are on stator. So one more difference, or we can say the construction difference, is that in case of conventional DC motors we have mechanical commutator, but in case of brushless DC motor this mechanical commutator is replaced by electronic commutator. So this overall decreases the loss component, so we can say the losses are reduced and efficiency is increased. If we compare the brushless DC motor with conventional DC motor, it has number of advantages. That's why it is more preferred, and we are working on applications are increasing. So as we have discussed, it has no mechanical commutator. So the mechanical commutator is absent, and electronic commutator is replacing the mechanical commutator. So overall, we can say the life of the machine increases because wear and tear and maintenance is reduced. And this machine also have low radio frequency and electromagnetic interferences. So overall performance is getting better. The DC machines generally run to a specific speed range, but when we talk about BLDC, brushless DC motor, they have very high speed range, and we can say if we compare the BLDC and conventional DC motor, the range is high, and the BLDC motor have better efficiency in comparison to conventional DC motor. So this is a circuit diagram. If we talk about its two parts, stator and rotor, so you can see rotor is consist of permanent magnet and stator is consisting of three binding, which are armature winding, and voltage source inverter is there, and the Hall effect sensor, they sense the position of the rotor, and accordingly they give the output signal, and that control system will give the signal to the switch, and the corresponding switching of on or off of the switches will be done on the basis of the control system output which are given to the switch of the electrode converter. So this is the basic structure and basics of this machine. Thank you. Thanks a lot.